Hello, this is a lesson on how to do more difficult mole concept question. Okay, let's look at this example. Okay, you have a nitric acid. You are given this chemical equation: nitric acid, sodium hydroxide, sodium nitrate, as well as water. Now this chemical equation has been provided to you, and then what you need, and then the question is, in an experiment, 1 mole of nitric acid reacts with 2 mole of sodium hydroxide. Now this is in the experiment. This one, the chemical equation tells you what happened in theory. Okay, so you have to compare theory and actual, or theory and in reality. Okay, so as usual, you write down in theory. In theory, what happened is 1 mole of nitric acid react with 1 mole of sodium hydroxide. This is in theory. In actual, in reality, what happened is you have 1 mole of nitric acid reacting with 2 mole of sodium hydroxide. So 1 mole of nitric acid, 2 mole of sodium hydroxide. Now in theory, 1 mole of nitric acid, for every 1 mole of nitric acid, you need 1 mole of sodium hydroxide. In the experiment, you have 1 mole of nitric acid. So according to theory, for that 1 mole of nitric acid, you need only 1 mole of sodium hydroxide. But now you have 2 mole. Okay, 2 is more than 1. So your sodium hydroxide is the excess reactant. Okay, so to answer the question, identify the excess reactant. That would be your sodium hydroxide. Now let's look at the second question. Question B. Calculate the mass of sodium nitrate produced. Now the mass of the product produced in a chemical reaction depends on the amount of limiting reactant. Okay, so what happened is this sodium hydroxide in part A, we found out that sodium hydroxide is the excess reactant. Out of these 2 mole, only 1 mole react. The other 1 mole is doing nothing there. Therefore, we do not use excess reactant to calculate the product, the amount of product that we'll get. So the amount of product that you will get in a chemical reaction always depend on the limiting reactant. So in this case is 1 mole of nitric acid. So in order to do this question, okay, the working is very simple. So it depends on the limiting reactant. So limiting reactant in this case is HNO3. Okay, HNO3, so you have to look at the mole ratio. HNO3 and sodium nitrate, what is the mole ratio? Because we want to calculate mass of sodium nitrate produced. So sodium nitrate is here, and the amount of sodium nitrate that is produced depends on the limiting reactant, which in this case is nitric acid. So we have to look at the ratio of these 2 chemicals. So nitric acid to sodium nitrate, what is the mole ratio? The mole ratio, the balanced chemical equation will tell you 1 and 1. So the mole ratio for nitric acid to sodium nitrate is 1 to 1. Okay, so we go back here and write 1 is to 1. So that means 1 mole of nitric acid produces 1 mole of sodium nitrate. But the question wants mass. So you have to ask yourself, 1 mole of sodium nitrate, what is the mass? So 1 mole of sodium nitrate, what is the mass? So the mass would be the number of mole times the MR. The number of mole is 1. MR, what would be the MR of sodium nitrate? The MR for sodium nitrate would be 23, which is the AR for sodium, plus the AR for nitrogen is 14, plus the AR for oxygen is 16, but there are 3 oxygen atoms there, so they'll be like that. And if you do the calculation, you find that, let me calculate, you find that the answer is 85 gram. Okay, so the answer is 85 gram. Let me calculate one more time. 16 times 3 plus 14 plus 23. That's correct, 85 gram. Okay, so always remember the mass of the product depends on the amount of limiting reactant. And the limiting reactant in this case, we found that from part A, the excess reactant is sodium hydroxide. So the limiting reactant is supposed to be nitric acid. And nitric acid, how much nitric acid is used in the chemical reaction? 1 mole. 1 mole of nitric acid. So 1 mole of nitric acid will produce how many mole of sodium nitrate? You have to look at the mole ratio of nitric acid and sodium nitrate, which from the balanced chemical equation, the mole ratio is 1:1. So 1 mole of this sodium nitrate would produce 1 mole of sodium nitrate. And 1 mole of sodium nitrate, the mass would be 1 times the MR, and that would be 85 gram. Right? Let's look at the second example. Now the second example is very similar, but it's harder than the first one, just a bit harder. Now same thing, the balanced chemical equation has been provided to you, and this is the question. In an experiment, 126 gram of nitric acid reacts with 60 gram of sodium hydroxide, and you have to identify the excess reactant. So same thing, whenever you're required to identify excess or limiting reactant, you have to look at the theory and the actual. So same thing, I write down here, in theory, that would be according to the balanced chemical equation. Okay, in theory, 1 mole of nitric acid react with 1 mole of sodium hydroxide. Now how about in the experiment, in reality or actual? In reality or actual, you have 168 gram of nitric acid, but this 126 gram, you have to change it to mole so that you can compare with the theory, because the theory is in mole. So 126 gram mass, how do you change it to mole? It must be mass divided by the MR. So in order to divide the mass by the MR, you have to find out your nitric acid. What is the MR? So what is the MR of nitric acid? Okay, show your working. Nitric acid, what is the MR? 1 plus 14 plus 3 times 16, and that would be 63. So, okay, MR, there is no unit, 63. So your HNO3, 126 gram. So number of mole is 126 gram divided by the MR, which we found just now, 63, and this equals to 2 mole. Okay, for nitric acid in the experiment, 2 mole of nitric acid is used. How about for sodium hydroxide? Sodium hydroxide is 60 gram. So same thing, you have to find out the MR for sodium hydroxide. MR for sodium hydroxide, what is the MR? What is the AR for sodium? 23. AR for oxygen 16. AR for hydrogen 1. And this will give you 40. Okay, likewise, the 60 gram here, mass divided by the MR would give you the number of mole. So 60 divided by 40, and that would give you 1.5 mole. Okay, so now it's time to compare the actual and the theory. Theory, for every 1 mole of nitric acid, need 1 mole of sodium hydroxide. Actual, 2 mole and 1.5. Now, in order to properly compare the actual and the theory, the basis of comparison must be the same. Because this one, 1 mole of nitric acid, so you can actually ask yourself, if 1 mole of nitric acid need 1 mole of sodium hydroxide, what if you have 2 mole of nitric acid? How much of sodium hydroxide would you need? Of course, you would need 2 mole. So now you compare 2 mole with this 2 mole and 1.5 mole. Now you can compare them because the basis of comparison are the same. They have the same basis. 2 mole, 2 mole, 2 mole, 1.5. So the theory say for every 2 mole of nitric acid, we need 2 mole of sodium hydroxide. In the experiment, we use 2 mole of nitric acid, but we only have 1.5 mole of sodium hydroxide, and this 1.5 mole is less than 2 mole. So your sodium hydroxide is the limiting reactant, which means that your nitric acid is the excess reactant, because the question asks you excess reactant, so that would be your nitric acid. Okay, so in order to compare the theory and the actual, the basis of comparison must be the same first. Otherwise, it is like comparing apple and oranges. They are not the same. Now the second part, for part B, you have to calculate the mass of water produced. Water is a product for this reaction, water. So remember just now for question 1, in order to find out the product, the amount of product produced, you have to look at how much of the limiting reactant that you used. So for this question, the limiting reactant is sodium hydroxide. So the amount of water that you will get depends on the amount of sodium hydroxide that we used. Now the sodium hydroxide that we use in this experiment is 1.5 mole. So you have to look at the mole ratio of sodium hydroxide and water. The mole ratio is 1 mole to 1 mole, which means that since now we use 1.5 mole of sodium hydroxide, we would have produced 1.5 mole of water. Now how to show the working? The working is like this. So we have to look at the mole ratio of sodium hydroxide, which is the limiting reactant, sodium hydroxide to water. Mole ratio, what is it? 1:1. How do I know it's 1:1? Look at the balanced chemical equation. 1 here, 1 here, which means that 1:1, the mole ratio for sodium hydroxide and water. Okay, the amount of limiting reactant used is 1.5. So 1.5 mole, 1 mole of sodium hydroxide produces 1 mole of water. So 1.5 mole of sodium hydroxide would similarly produce 1.5 mole of water. And the 1.5 mole of water, the question wants mass. So what would be the mass of 1.5 mole of water? There will be mole times the MR of water. And the MR for water, you know, is 18, and that would give you 1.5 times 18, 27 gram. Okay, so again, the key point here is the amount of product produced depends on the amount of limiting reactant that we use. The limiting reactant in this case, which we found out from part B, is sodium hydroxide, and we use 1.5 mole of sodium hydroxide. Okay, 1.5 mole, 1.5 mole of water would be produced, and 1.5 mole of water, the mass is mole times the MR, which is 1.5 times 18, and that would give you 27 gram.